Thank you so much for joining this lesson. We're going to discuss linear inequalities. This is a topic which is both in CBC and also in the 844 system. So we'll be helping the grade 9 learners to prepare for the Kcse and also the secondary school students to prepare for Kcse. So if you know anyone who is expecting those national exams, please invite them to this broadcast. Number one, we're going to handle some inequalities whereby we will solve both simple and compound inequalities. Then after that, now we'll be embarking on the graphical work. So number one, we are taught to solve the following inequalities and represent the range of values of x on a single number line. These are two inequalities. The first one is here. That is inequality 1. Then we got inequality 2 here. The first one is 5 minus 3x greater than negative 7. So that is what we are going to simplify first. It's unsimplified. So we first simplify this statement. Then after getting a simple statement, we also simplify the second one and get another simple statement. Then we'll be combining that. So having 5, then negative 3x greater than negative 7. Now, this is how we're going to simplify it. The best way to simplify is to first group terms together. Therefore, I will have this negative 3x remaining here. Then this is greater than. When we are having negative 7 there, then this is negative 5. Because positive 5 going to the right-hand side will become positive. So it will be a negative 12. Because negative 7, negative 5 will take us to negative 12. Now we are supposed to divide through by negative 3, so that we remain with x here. But something very serious that we're supposed to note is that when we divide by a negative, when we divide or multiply by a negative number, the sign reverses. The inequality symbol reverses. So that is something you're supposed to know. So instead of greater than, now we shall have less than. And when negative 12 is divided by negative 3, now we get 4. So this is the simplest form of the first inequality. The same inequality can be solved in a different way, and that is because it is not all the time when the learners will be aware of this note, such that when a negative divides or multiplies, we reverse the cycle. We can avoid all that by ensuring that we do away with the negative in this way. Instead of taking 12, instead of taking 5 to the right-hand side, now we'll bring 7 to the left, such that it is 5 plus 7, and that will give us 12. Then this will be greater than, instead of 3x, which is negative, now it becomes 3x positive to the right-hand side. So that to remain with x, we shall have 4 on this side. So you will discover that the simple statement x less than 4 is just the same as 4 greater than x. So when we say x is less than 4, technically we mean 4 is greater than x. So these two statements are meaning the same. These two simple statements have the same meaning. So instead of dividing by a negative, which reverses the symbol, we can simply do away with the negative and the work becomes even more easier. All right, the second inequality, which is x minus 6 less than or equal to 3x minus 4. Now you see this one now. Let me show you how we can make it even simpler. Because 3x is already on the right-hand side and we have x, on the left. Now we can bring it to the right, where it will be subtracted. So on the right hand side, I'll be having 2x instead of 3x. Then here I'm having less than or equal to. Now 4, which is negative, becomes positive on this side, such that now we are having negative 6 plus 4. So negative 6 plus 4 will give us a negative 2. Then now to remain with x here, we'll have to divide through by 2, whereby this becomes a negative 1. This becomes a negative 1. So this is the second inequality, again, simplified. So you see we have the first one here, simplified. The second one here, simplified. And because they are simultaneous inequalities now, they will have to represent a given range, whereby negative 1 is less than or equal to x, and again, x is less than 4. Therefore, the range of x will be from negative 1, x, so from negative 1 all the way to 4. You know, this is now the combined statement, which is supposed to be represented on a single number line. A single number line. So I'm drawing the number line now. This is a 0, 1, 1, 2, 3, 4, 5, negative 1, negative 2. Therefore, we are starting from negative 1 all the way to positive 4. And something you're supposed to notice that negative 1 is included because we have less than or equal to. So negative 1 is included. Now that it's included, we will have to shed that limit because of the inclusion. But positive 4, which is not included, we just have to circle it to show the limit, but not included. Therefore, this is the range of values represented on a single number line, from negative 1 all the way to positive 4. So you're supposed to know that for grade 9 learners, according to your level, you are just supposed to know how to group terms in an inequality like that, and you simplify it the way we have done. In case you encounter a negative, you can solve it by ensuring that once you divide through by a negative, you reverse the symbol, or you can do away with the negative by taking the sign to the other side of the inequality symbol, such that it becomes positive instead of working with negatives. So find the range of values of x. Find the range of values. So we're going to do the same thing here. And this now is likely to be simpler. From 1, we can see x will just come there, so that we have 3x. Then this one is less than or equal to 6. To remain with x, we shall have this one as 2. Imagine that one is already simplified. I've divided through by 3, getting x less than or equal to 2. Then in the second one, I have again to work with negatives. There is a negative 3x here. So when we take it to the right, that will be 6x. Then now this 4 will be added to this side, so that we have a 8 minus 4 becomes positive 4, which is now 12. Which is now 12. So you see now we are having a, when we divide this by 6 and by 6. So 2 less than or equal to x. 2 less than or equal to x. So that is those are the two simplest statements, the two simplest statements. Now, after knowing how to simplify simple statements, it's good for you to know that apart from representing on number line, some other times you'll be told to state integral values. Write down the integral values. Find all integral values. Integral values. So we're going to solve one that involves integral values before we get into the graphical work. But look at it this way. This one is a compound statement now, not simple statements. A compound statement whereby we have two inequalities. So the first thing you're going to do, you split the compound statement into two simple statements. So from -3, the first statement should run all the way up to just before the second inequality symbol. That way. So from -3 to +6, that is one inequality. Let me put it down here. -3x plus 2 less than x less than x plus 6. So that is the first statement. Now, the second simple statement, which is supposed to be extracted from this compound statement, should start just after the first inequality symbol all the way to the last term. Therefore, we'll begin from x all the way to the last term. That is now the second inequality. So x plus 6, x plus 6 less than or equal to 17 minus 2x. Yeah, 17 minus 2x. So I have my two simple statements. So now, whether you are in grade 9, Form 2, Form 3, or Form 4, you are able to solve the first inequality and also the second inequality. In grade 9, we may not have the simultaneous solving, but at least we can solve each inequality independently. So the first one, if we begin solving now, allow me handle this one by doing away with what we are calling a negative. That way, I will have to transport -3 to the side where there is x, and it will become positive. So we shall be having 4x, because -3 becomes positive. X plus 3x, so we get 4x. Then 6 should be brought to the side where there is the other constant. So 2 minus 6 will give us a -4. You see now when we divide through by 4, you have to get x, and this is a -1. So the first simple statement has been solved. The first simple statement has been simplified. What about the second one? In the second one, again, to do away with negatives, we have to bring -2 to this side where it will become added. Therefore, x, now we will add 2x, and that will be 3x. Yeah. Then we have a less than or equal to 6 should be brought to this side, whereby it will be 17 minus 6. You know, 17 minus 6 is 11. Therefore, x less than or equal to 11 out of 3. This gives us 3.667. 3.667, trying to make it for SF. So when I try to combine now these two symbol statements, I will be having all the way from -1 x, then x now is less than or equal to 3.667. So this is now the combined statement for the two inequalities. So now I have to state what we are calling integral values. So for me to state integral values, I have to consider between -1 and 3.667, which are the integral values there, considering a number line, a simple number line. And you will discover that 1 is not going to be included because the limit here is strictly less than. If it was less than or equal to, we would have included -1. So we will start with 0, and it's good for people to note that 0 is an integral value. Then after that, we go to 1, then we go to 2, then we go to 3. Now, something very interesting here that learners are supposed to learn is that there is inclusion at this point. We have less than or equal to 3.667. Now, what you are supposed to understand is that 3.667, even if it is an inclusive boundary, it is not an integral value. Integral values are numbers, including 0, both positive and negative, except fractions and decimals. So this being a fraction, this being a decimal, that is, which can also be converted to a fraction, is not an integral value. Therefore, we go up to exactly 3. So those are the integral values we were supposed to come up with. Now I have to check something on the graphical work. As we transition to the graphs, let me remind you of our program here, whereby you can purchase airtime from all the networks just from your M-Pesa. You go to M-Pesa, the M-Pesa menu, Lipa na M-Pesa, then the business number, which is our pay bill, is 737356. Then now the account number is the phone number that you intend to purchase airtime for. After that, now you will enter the amount of airtime that you'd like to spend. Then complete your transaction and you'll be receiving your airtime instantly. So please use this facility and invite your friends for the same. Now, on graphical work, allow me begin by a question which involves plotting the line, or plotting the inequalities, that is, representing inequalities graphically. So that from there now, we will interpret plotted inequalities so that we may make them plotted inequalities so that we may know the inequality which had been plotted. So for now, let's use provided inequalities here. By drawing appropriate straight lines on graph paper and shading the unwanted regions for each line, illustrate the region which satisfies all the inequalities below. So the language of region may not be common to the grade 9 learner, but plotting of lines and shading an required region, that one now is your level. So let's first plot lines and shade where they should be shaded. I would advise learners for lines like 1 and 2, let people embrace the concept of straight lines in grade 8 for the CBC and Form 1 for the 844. 844, whereby you are just given equation of a straight line and you are expected to come up with a table of values. And now you have to plot them and draw the line. In this case, the inequalities are supposed to be translated into their respective borderlines, which are equations of straight lines. Therefore, the first inequality should be translated into a borderline, which is 4y minus 3x equals to 12. So there is a borderline which represents the first inequality, and that borderline is the respective equation. So from this equation, can we get a table of values? Yes, let's do that. A table of values whereby we have to get x, y, then a minimum of 2 values so that we may plot these values x, y. Again, at this point, you will allow me to use the concept of what we call intercepts. Intercepts are points where a given line is cutting the y-axis and also the x-axis. Those are the points when x is 0 and also when y is 0. So when x is 0, according to the equation above, what is the value of y? So 4y minus 3, the value of x is 0. equals to x. So 4y equals to 12, and y becomes 3 after dividing through by 4. So that is the y-intercept, which is at point 3. Again, we ask ourselves, at the point when y equals to 0, what will be the value of x? So we go back to the same equation and say, where there is 4, we substitute by 0 minus 3x equals to 12. So this shall be 0 minus 3x equals to 12, this 3x. So to remain with x, we should talk about negative 4. So x-intercept is negative 4. And now, this one can be plotted. This one can be plotted. All right, they have already given us the Cartesian plane, which is already suggested. We have the Cartesian plane, and it's not accommodating negative 4 for the x values. Now that it is not accommodating negative 4, we will have definitely now to choose another coordinate, because a scale is supposed to be accommodative. Therefore, it is me now to play with these till I get values which will be accommodated to this scale provided. So I have to pick another coordinate. For example, when the value of x is 4, what are we going to have as y? When the value of x is 4, what are we going to have as y? So it will be 4y minus 3 into 4 equals to 12. So 4y minus 12 equals to 12. We see 4y equals to 24 now. So that the value of y becomes 6. So the value of y is 6. At least now we have an alternative coordinate there. So we can use those two coordinates. 0, 3, that is the y-intercept. The coordinate is here. Then 4, 6. So coordinate 4, 4, 6. Coordinate 4, 6 is at this point. So we have two coordinates which will need to be connected so that we get this borderline. But now something else which we are supposed to put into consideration is the inequality symbol used here. The inequality symbol is less than or equal to. So because of or equal to, the borderline is supposed to be a complete line. A complete line, not a dotted line. A complete line. Therefore, we join the 2 points using a complete line. So we use a complete line to join these 2 points. Let me do that. Sorry. Line. The straight line is line 4y minus 3x equals to 12. 4y minus 3x equals to 12. So we have the first line already established and plotted. Let's check the second line. Second line now. I hope this one will accommodate the intercepts. So for the second line, we are supposed to talk about values of x and values of y. But let me do the table here. I only need x and y. Then when x is 0, what will be the value of y according to the second equation? Remember, the second equation should be translated to 6y plus 5x. This one is equal to 60. So that is what we call the borderline to represent the inequality. Therefore, when x is 0, we can get the value of y by saying 6y plus 50 equals to 60. So 6y, sorry. The other one becomes 0. 6y equals to 60. So the value of y equals to 10. Y equals to 10. Then again, we ask ourselves, when y equals to 0, what will be the value of x? So according to the same equation, we can have 6, then y is 0, plus 5, the value of x equals to 60. So 5x equals to 60. Remember, this one becomes 0. So the value of x becomes positive 12. So x is positive 12. So for the second borderline, we can plot the two coordinates now, which are the intercepts. So we'll be having 0, 10 and 12, 0. So 0, 10, that will be the y-intercept. 0, 10 is here, the y-intercept. And we will also talk about the x-intercept, which is coordinate 12, 0. 12, 0. So coordinate 12, 0 is here. 12, 0. Yeah. Coordinate 12, 0. So let me put across now the line 12, 0. Yeah. Something else we are supposed to remember is that this line is supposed to be dotted. This particular borderline is supposed to be dotted. The borderline is supposed to be dotted. Because of this, we are dotting the borderline because the inequality symbol used is strictly less than. Now, if it was less than or equal to, we would have had a complete line. But now that it is strictly less than, the borderline is supposed to be dotted. So line 6y plus 5x, line 6y plus 5x equals to 60. So that is the line that we have plotted. Yeah, so that is it. We can check some more lines, like y greater than or equal to 3. So y, this one is equal to 3. So let's check line y equals to 3. So we go to the y-axis and identify where 3 is. And we can automatically see where 3 is. So along that line, now we draw our borderline. And remember, it is greater than or equal to. So the borderline is supposed to be complete. So we will have a complete borderline here. Complete borderline that way, which is line y equals to 3. That is it. Y equals to 3. Now check here. The last one, x equals to 2. X equals to 2 is here. X equals to 2. We translate the inequality into a borderline. X equals to 2. So x equals to 2, we go to the x-axis, and at x equals to 2 now, we have to draw our perpendicular line there. Again, a complete line. So x equals to 2 is here. X equals to 2 is here. Yeah. X equals to 2 is going to be here. Is the line. X equals to 2. Now, the other thing is to do what? Shed the unwanted regions so that we may illustrate the common region which is bounded by all these inequalities. So when you look at the lines, there is a common region which has been bounded by the 3 inequalities, and that is the region R at this point. The region has been bounded by the first line that we drew. If we can call it L1, then L2, then we add L3, and now we're having L4. So all the lines are giving us a common region, which means for these particular lines, automatically we will have the shading of their outer sides in this manner. So we have to shade the outer side. Remember, the lines have already shown us the region that we need. So now that region R is the required, then this side is not required. And for L2, this other side is not the required side. So we shade the unwanted. And for this other line, we shade this side. So that at the end of the day now, we will have our common region surrounded by all the border lines. So that is how we plot the border lines. And at the end of the day, they must outline. At the end of the day, they are outlining the region which is bounded or which is surrounded by all of them. So that is the common region surrounded by all of them. Now, there is something that I want us to do now. There's something I want us to do in this lesson, whereby assume that we are all in grade 9 and we are not going to come up with a region. We are just supposed to represent a single inequality on the whole Cartesian plane. How shall we identify the side to be shaded? How shall we identify the side to be shaded? So we have to work now with such a question, and you will allow me to plot some two inequalities here. Assuming that we were to plot the inequality, yeah, that inequality, the second inequality there. So we are plotting inequality x plus y greater than or equal to 5. Greater than or equal to 5, and we are supposed to know the side to shade it. Yeah, assume it is this one provided alone without other inequalities. You know, in the previous question here, we have been guided by the 4 inequalities such that after they have guarded a common region, now we have automatically concluded the sides which are supposed to be shaded. But now in this case, I want us to assume that what has been provided is just this inequality. Only this one has been provided. Then we have to plot it on a grid and shade the unwanted side. How shall we come up with that unwanted region? A table first. X, Y. So a table X, Y, we can have the value of X is 0 and know what Y will be. So the inequality here will be X plus Y equals to 5. So we have to come up with an equation which will represent the inequality. So when X is 0, Y will be equal to 5. So Y equals to 5. So the value here is 5. Then again, when Y is 0, what will be X? So we go back to the same equation and say X plus Y, which is a 0, equals to 5, meaning that the value of X becomes 5. So X is 5. So we have 5, 5 as the inequalities. So let me now draw 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Can have -1 here and also -1 on the y-axis. Now with this, we have to connect coordinates 0, 5 and 5, 0 each way. We also have to remember that the line is going to be a complete line because the inequality is greater than or equal to. Greater than or equal to. So now I'm supposed to do the straight line by connecting the two coordinates. We do the straight line by connecting the two straight lines. So let me do that. So now we are having our line here. Let me label the line. This is line. x plus y equals to 5. X plus y equals to 5. That one now is done. But now, which side of this line are we going to shed? So we are going to examine the two sides of the line so that we may know which side is going to suit the inequality up there. So remember, we are having x plus y being greater than or equal to 5. So if we pick a coordinate at this side, for example, we have picked coordinate 4, 5. We are supposed to place it in the above relationship so that we may see, are the two sides of the inequality going to obey the inequality symbol used in this manner? If we substitute x with 4 and y with 5, so it will be 4 plus 5. Then the other side of the inequality is having 5. So when we take 4 plus 5, I'm getting a 9. And what we are having here is 5. Now we examine the relationship between 9 and 5. Is it that of greater than? Very true. 9 is found to be greater than 5. Therefore, when we pick a coordinate on the upper side of this equation, the coordinate is agreeing. After being placed in the inequality, it is agreeing with the symbol used there. We find that the left-hand side is becoming greater than the right-hand side. So this is now the required side. And this means for this particular inequality, we are only supposed to shed the other side because we have confirmed that the upper side is the wanted side. The upper side is the wanted side. We can also confirm that this other side was the unwanted one. If we pick a coordinate like 1, 2, for example, we pick a coordinate 1, 2, and we place it in the same. We examine now this inequality, 1, 2. So we have to say mali kuna x, we place 1, and where there is y, we place a 2. Remember, on the right-hand side, we are having a 5. So 1 plus 2 is 3. And on the right-hand side, we are having a 5. Therefore, 3 and 5, when you compare their relationship, you discover that 3 is less than 5. And now, the inequality used in this, the inequality used here is that of greater than. Therefore, the coordinate we have picked after examining it is not agreeing with the inequality used. Therefore, we will say that this side is supposed to be shaded. It is the wrong one. So it is confirming that truly it was not the wanted side. So you usually pick a coordinate from any side and you prove it. You examine it following the inequality symbol, which is in application for the particular question. Yeah, that is it. That is it. That is it. So I can actually use the grid here to confirm. Just one more equation for you so that you may understand what is happening. And remember, our consultation line remains 07, 04, 15, 33, 66. Yeah. So now let me pick another coordinate. I'm doing this one for the sake of grade 9 learners who might not plot all inequalities on one Cartesian plane. Therefore, I want to help them to learn how to identify the side which has to be shaded. X plus y less than or equal to 10. X plus y less than or equal to 10, which means the equation to represent the inequality is x plus y equals to 10. So we come up with a simple table whereby we can have x as 0. So when x is 0, what shall we have as the value of y? So we have x as 0 plus y equals to 10. So y equals to 10. Then again, we pick a value at y equals to 0, what shall we have as x? So when y is 0, we can get the value of x. Again, the same equation, x plus y being 0 equals to 10. So x equals to 10. X 10. Therefore, we can use these intercepts at 0, 0, 10, and 10, 0. Those are the coordinates we are going to draw. Remember, the inequality symbol used is less than or equal to, meaning that the line is going to be a complete line. So let's join using a complete line. We join using a complete line. So let me do that. Remember to subscribe to this platform. Remember also to share the link with friends. Yeah. Check now. My borderline has been very well. So x plus y equals to 10. X plus y equals to 10. Yeah, that is now the line. The line has been represented. The line has been represented. So after that, how is to identify? Is this line going to be shaded on this side or on this side? Now the ball is on our side. This is how we determine it. We pick a coordinate on any side. Let's say I begin by picking a coordinate here. What will be this coordinate? This is coordinate 7, 8. 7, 8, which is on the upper side of the line. Then we will place it here and check what the relationship is going to be. When we pick x as 7 and y as 8, then on the right hand side we're having a 10. Now this is 15 and this is 10. 15 and 10. Now, how is 15 and 10 related? You discover that 15 is greater than 10. If 15 is greater than 10, if 15 is greater than 10, now, according to the inequality symbol used, is it that one of greater than? No. If it is not that one of greater than, then we will say the coordinate that we have picked is just on the wrong side. And if it is on the wrong side, that automatically is the side to shed. Automatically, that becomes the side to be shaded. We can further confirm, though that is enough, we can further confirm that the other side, which has remained now, is actually the side which is right. By picking a coordinate like 4, 5. So coordinate 4, 5, when we take it to the inequality here and we replace it, where there is x, we put 4. Where there is y, we put 5. So it will be 4 plus 5, and on the right hand side, we are having a 10. So 4 plus 5 is 9. And now we ask ourselves, how is 9 and 10 related? 9 and 10 are related in such a way that 9 is less than 10. Therefore, this automatically becomes the right side. Now, if this is the right side, now it has to remain unshaded the way we have already done. It's good for you to know the coordinate you have picked on any side represents all the other coordinates on that particular side of the line. All the other will obey the same. All the others will obey the same. So that is what you're supposed to know. So now we can check. We can check now the cases whereby inequalities have been plotted. Inequalities have been plotted, and it is upon us to determine the inequality being represented. The area is already here. The inequalities are already plotted for us. So it is upon us now to know which inequality was plotted in which graph. So that is the work that we're going to do right away. We can begin with the questions are several. The questions are several, you see. This is one. So there are several. Look at this question. In the figure below, find the inequalities which describe the unshaded region. The inequalities that describe this region. And we have the inequality represented by L1. We have the inequality represented by L2. L2 is here. Then L3 is here. So we can begin with L1. The coordinates that we can pick very quickly and use them are the intercepts, whereby there is 1 here. The other intercept is 4. So for L1, we can say that some of the coordinates lying on that line are 1, 0, and the other one here, which is a 0, 4. So we got inequalities already. We got coordinates. So let's find the line. The line which was plotted as L1. So to find this line, we have to begin by getting the gradient of this line. And the gradient of this line is going to be, we have to take change in y. So 4 minus 0 divided by change in x, 0 minus 1. So this shall be 4 out of -1, which is just -4. So we are having a gradient as -4. We are also having the y-intercept as 4. So coming up with this equation will be very easy. Remember, we know that in the general equation, y equals to mx plus c, this one is usually the gradient, and this one is usually the y-intercept. Therefore, with y-intercept and also gradient, we can express the equation very quickly by saying the equation will be y equals to, instead of m, we have the gradient -4x. And instead of c, we have the y-intercept 4. According to the drawn line, it's cutting the y-intercept at 4. Therefore, we imply directly. So this is now the equation. The equation for the borderline L1. The equation for the borderline L1. If we are having the equation that way, now we can examine the inequality which was plotted. And what do we do here? We have to pick a coordinate which is within the required region. And the required region of this side is here. We have region R. So with region R, we can pick any coordinate. Allow me lift this coordinate here. Just any coordinate, as long as it is within the required side. So this coordinate is -1, 2. Yeah, the coordinate is -1, 2. -1, 2. So with the coordinate -1, 2, which is within the required region, we have to examine when this coordinate is replaced in this equation, how are the two sides going to behave? How are the two sides going to behave? So where there is y, we will put 2. So in this equation now, where there is y, we have to put 2. And where there is x, we put a -1. So negative, this is on the left. So on the right, we will have -4. The value of x is -1, then +4. So this is 2. But on the right-hand side, now we're having +4 plus 4, which is 8. So on the right-hand side, we are having 8. On the left-hand side, we are having 2. And the main question is, how is 2 and 8 related? 2 and 8 are related in such a way that 2 is usually less than 8. So this has now given us, because the coordinate has been picked from the required region, the inequality to be used there instead of equal sign. Now the inequality was y equals to, sorry, not equals to now, but less than y less than negative 4x plus 4. And finally, something else that we are also supposed to note is that according to the plotted borderline, it is a complete line. So being a complete line, we have to know that apart from less than, we are also having or equal to. If it was a dotted line, then we would have said it is strictly less than. But now that there is a complete line plotted here, then it is less than or equal to. So this is the inequality which has been represented by the borderline L1. By the borderline L1. We can do the same for just for people to understand more how to come up with inequalities. Yeah, we can do several. We can examine several. Let's check the second line, L2. The second line, L2. The second line, L2, which is here. Let's get the sum of the coordinates lying on L2. Some of these coordinates, I'll pick here, negative 3, 0. Then we are also having 0, 4. 0 for that. So can we get the gradient by taking change in y, which is 4 minus 0. Change in x, 0 minus negative 3. So you see now, this is 4 out of positive 3, because minus negative 3 becomes a positive. So the gradient there is a 4 over 3. And the y-intercept is still 4. So the equation will be written where there is m, we put a gradient of 4 over 3 x plus the y-intercept of 4. We are now having the equation of line L2. Now that we have the equation, we can still progress with the equation this way. Yeah, we can progress with the equation this way. And we can also do away with the fraction. So this inequality can also be, this equation that is, can also be, we multiply through by the 3 found here, the 3 at the denominator, so that we have 3y equals to 4x plus 12. Yeah. So the two inequalities are just the same. You can work with any. So assume now we have to work with the first one. Assume we're supposed to work with the first one. I'll pick a coordinate which is within the required region, a coordinate like 0, 3. Coordinate 0, 3. So we will replace coordinate 0, 3 in this equation so that we may see the relationship of the right-hand side and the left-hand side. Where there is x, we shall have 0. Where there is y, we shall have 3. Therefore, where there is y, we have 3. Then on the right-hand side now, you will be having 4 over 3 multiplied by 0. And we add 4. So this will be 3 and 0 plus 4. So 3 and 4 have a relationship. What is the relationship between 3 and 4? And the relationship is that 3 is usually less than 4. If 3 is less than 4, then the inequality symbol to be fixed there is less than. So the inequality becomes y less than 4 over 3x plus 4, like that. But now we have to include again or equal to, simply because the borderline is a complete line. The borderline is a complete line. Now that the borderline is a complete line, we are not supposed to forget that relationship. I repeat again, if it was a dotted line, we would have had strictly less than. So that is it. But looking at the second expression, which is just the same, looking at the second, we can also check which symbol will be here. 3 multiplied by the value of y. So that will be 3 multiplied by the value of y according to the coordinate we picked. The value of y is 3. So this will be 9. What about on the right-hand side, whereby there is 4 over 3, 0 plus 4. So this is going to be 4. Now, how is 9 related to 4? You see, 9 is going to be greater than 4. And now that 9 is greater than 4, then when the inequality changes to this, when it changes to this, it is now going to be otherwise. So it will be 3y greater than or equal to 4x plus 12. So that is simply how we're supposed to identify the symbol to be used. Thank you so much for following. Remember to subscribe and to share.